Okay, in this video we want to look at titrations. Basically, we're going to go through a couple scenarios. The first one I want to go through with you guys is a strong acid, strong base. And what we have here is we want to calc the pH, so just always keep track here of what we're calculating. That way we make sure it's not pH, concentration of H, whatever we're looking for. We want to calculate pH after the total volumes. Be sure this is total volumes of 250 HCl has been added to 50 mils of 1 molar NaOH. So the NaOH is going to be sitting down in the bottom. What we have here is a little flask, and that's going to have our NaOH down here in the bottom. And what we're going to do is add successive amounts of HCl to that from a burette. And we're going to calculate the pH at varying volumes of HCl that's been added. So the first one is we're going to add 4 mils of HCl. 4 mils of HCl. Now, we've calculated before here, we have the volume and the concentration. So our NaOH is 0.075. Now, these strong acids, strong bases are cake. All you have to do is find out how much of your sample you have, then find out how many moles of the titrant, that's what we call this substance up in the top here, that's our titrant, we're adding, and then see which one's left over. That's going to determine my pH. So in this case, I added 4 mils of 0.250. That's going to give me 0.001 molar. Okay? Mole. I already have 0.075. So if we subtract the 0.001 from the 0.007, I got 0.65 moles left over. Now, yes, we also made 0.10 moles of NaCl, but NaCl is a salt, and we know that that's basic. Or we know that that's neutral. So we don't need to worry about that. That's pretty insignificant. So now what we have is 0.065 mils. And we need the total volume. That's going to come from our 50 mils of base and our 4 mils of acid. And we're going to turn that into liters. We have 0.120 molar NaOH left over. We look at that, take the negative log. Negative log 0.1 is about 1. We subtract that. That's a POH. So we subtract that off, and we get a nice volume of 13.1. That's pretty simple. Now this next one, we're going to add a fresh, total volume of 29.5. So if we already added 4 mils, we're going to add another 25.5 mils to this. Same scenario, find out how much HCl you have, how much NaOH you have, subtract the smaller from the bigger, get the molarity, calculate the POH, and we get a pH here. And our pH is going down. We started out at 13.1. We're going down to 11.2. And that makes sense because, well, we're adding an acid to a base. That's a very good thing. Now, in C, we're going to jack this up and get to a complete 30 mils of HCl. At 30 mils, we have an equal number of moles. This is going to be called the equivalence point. That's the point where we have equimolar, equal number of moles of acid and base. At that point, if it's a strong acid, strong base, we're done. The pH is 7. No calculation necessary. Doesn't matter which strong it is. That's just the pH at equivalence. And we know that it's equivalence because we have nothing left over except a neutral salt. So now we've come and we've gone past the equivalence point in example D. Example D, we're just going to go from 30 to 30.5. We're going to add just a half a mil more of acid. So now I've got 75 of our base right here. I'm adding 7625 of our acid. We got a little bit of acid left over. My H is in excess. We find out the moles of excess. We find out the volume that the total is. We have 50. The way we got that 0.085 is 50 plus 30.5, 80.5, and turn that into liters. That's now our concentration of H plus. Okay, now we're on the other side of the equivalence, so now we're calculating H instead of OH. That means our concentration, or our pH, just went down from 7 to 2.81. So what this looks like is we started out with a strong base. We're going to graph this a little bit. And we're going to look at pH, and we're going to look at volume of HCl. We started out with a strong base. It curved straight down and straight over. This is just a perfect sigmoidal curve, and right in the middle of that curve is the equivalence point, which in this case is equal to 7. It will only be equal to 7 because it's a strong acid, strong base titration. I'm Smath. That's a strong acid, strong base titration. Our next one, we'll talk about what happens when we have something weak.